The next topic in our factoring module is about using the difference of squares formula. If you recall, when you learned to multiply polynomials, you probably saw the formula that says when you multiply a minus b times the quantity a plus b, it turns into the binomial a squared minus b squared. This is called the difference of squares formula. Okay. Remember, factoring is the reverse of multiplying. So in this topic, we're going to use the difference of squares formula this way. Okay. So it's written down here, when we're factoring with the difference of squares formula, we'll start with a difference of two squares, something like a squared minus b squared, and we'll end up with a product of two binomials, a minus b, a plus b. So here's an example of how we can apply the difference of squares formula to factor a polynomial. So if we're given a polynomial like x squared minus 9, first of all, we recognize this polynomial as a difference of two squares, right? There's a minus sign, so we know it's a difference, and there's two perfect squares, x squared and 3 squared. So then we can use our formula, which says if you have a squared minus b squared, it turns into a minus b, a plus b. So if you have x squared minus 3 squared, it turns into x minus 3, x plus 3. Now this is a product, so we've factored the polynomial into a product of two other polynomials. A little side comment: in order to recognize when you can apply the difference of squares formula to help you factor, it's good to have your perfect squares memorized. Okay, in the last example, we had x squared minus 9. And our brains hopefully really quickly recognize that 9 was 3 squared. Okay, but if you're given something like x squared minus 289, if you don't have your perfect squares memorized, you may not recognize that this is a difference of two squares. Okay, in fact, this is x squared minus 17 squared, which then, through the formula, we know factors into x minus 17, x plus 17. Okay. So it's very helpful to have your perfect squares memorized up until at least 15 squared, which is 225. It's even better to go up to 20 squared, which is 400. So we're at the main idea for this topic, which is pretty straightforward. To factor a polynomial that is a difference of squares, apply the difference of squares formula. Okay. The tricky thing here is recognizing when you have a difference of squares. Okay. In order to have a difference of squares, you must have a subtraction sign. Okay. Don't try to apply the formula if you have an addition sign between your two terms. Right. And also you must have two perfect squares. Okay. So let's look at some examples so we can get used to applying this formula. Alright, so on to our first example. The instructions say factor each binomial completely. And we're given, in part A, the polynomial 4x squared minus 1. So hopefully you recognize that this is a difference of squares. Okay, clearly it's a difference because of the minus sign. Now the question is it a difference of squares? Well, to check whether this is a difference of squares, one thing you can do is take the square root of each term. Right? If you can find the square root of 4x squared, then 4x squared is a perfect square. So you know the square root of 4 is 2, you know the square root of x squared is x. So when you square 2x, you get 4x squared. Do the same thing with 1. The square root of 1 is 1. So when you square 1, you get 1 back. This means that 4x squared can be rewritten as 2x, quantity squared, minus 1 can be written as 1, quantity squared. And then we can apply the difference of squares formula, which says if you have a squared minus b squared, you get a minus b, a plus b. In the context of this problem, that means if you have 2x squared minus 1 squared, you're going to get 2x minus 1 quantity times 2x plus 1 quantity. Right, so we've used our difference of squares formula to factor 4x squared minus 1 into 2x minus 1, 2x plus 1. So for our next polynomial, 196 minus 225p squared, we're going to follow the same procedure. Right? In our head, we're thinking this is probably a difference of squares because first of all, we have a minus sign, so we know it's a difference. So then the question becomes, are these two terms perfect squares? We can check that by taking the square root. Is 196 a perfect square? Well, the square root of 196 is 14. Okay, so since the square root works out perfectly, we know that 196 is a perfect square. Is 225p squared a perfect square? Well, the square root of 225p squared is going to be equal to 15p. So both of these are perfect squares, which means we can rewrite the binomial as 14 squared minus 15p squared. The order here is important. The 196 is first, so you're going to write 14 squared first. The 225p squared is being subtracted, so you're going to subtract the 15p quantity squared. And then according to our difference of squares formula, you take the first term, the first quantity inside the parentheses here, and subtract the second. So you'll get 14 minus 15p times 14 plus 15p. And then we factored the polynomial.